Howdy guys, welcome to another stats video. Today we're going to talk about hypothesis tests, and the only tests because of the winter weather, the only tests that we're really going to talk about are one proportion z-tests. So this is sort of like building a confidence interval, but it's different too. So for all hypothesis tests, we need to check these kind of 5 things, okay? We state what test we're using, include if it's a Z or a T test, mean or proportion, 1 or 2 sample. So in a regular stats class, you would have Z test, T test, and then we would differentiate between means and proportions. So we're going to, one to right. We're going to do this for every hypothesis test. We're going to state the null and alternative hypothesis in the context of the situation. We're going to check our assumptions, state the value of Z or T, and the p-value. For this guy, we're going to use the bookmarked site under Blend for today. That's called one prop Z test. And then write our conclusion in context of the problem. So we're really just going to work one problem, and we're going to, they're long. So we're going to, let's read this problem real quick. Mr. Trinfield thinks that he can make 60% of his free throws. Coach Edwards thinks Mr. Trinfield is full of it and is worse than a 60% free throw shooter. Trinfield went to the gym and made 28 out of 60 free throws. Is this convincing evidence that Mr. Trinfield is worse than 60% at free throws? So the name of the test, since we only have one, this is going to be the easy part for you guys. One proportion z-test. Okay, we use one proportion z-test when we're trying to make a statement about a population, that would be all of Trinfield's shots, based on a sample. And the sample would be his 28 out of 60. We use the z-test whenever we have a supposition about a population, like his free throw shooting is 60% or not. So that leads us kind of to the null and the alternative. H naught is Mr. Trinfield makes 60% of free throws, or P equals 0.6. It's very important that we do this right. So this is a capital H, subscript 0, that's H null, and that's a colon, like the clock, a digital clock, like this down here. The alternative is capital H sub A, and it is Mr. Trinfield makes less than 60% of free throws, or P is less than 0.6. Okay, check the conditions for inference. So we're always going to check the same conditions. One is it a random sample. In this case, yes. We're going to assume these 60 shots are a random sample. Number 2, is it independent? Well, his number of shots, 60, is less than 10% trend fields, free throws. So yes. Okay, so as long as, we're going to consider it independent as long as the sample size, which is this one 60, is less than 10% of the population. Sure, let's assume that's true. He's making at least 600, or 10 times 60. Finally, is my sample size large enough? So we need at least 10 expected successes and failures. And we have that, right? He's making 28 successes, and then his failures would be 32. And then we're going to check this too. The sample size times the null hypothesis percentage, or the suspected population percentage, proportion. That has to be greater than or equal to 10. And it is. We also want to check that our sample size times the complement of this guy, or 0.4, is also greater than or equal to 10, and it is. So you got to check all that. Those are all conditions. This is what we want to do for every single hypothesis test. State the name of the test, state the null and alternative hypotheses, check the conditions, and you're going to notice conditions are the most we write, but it's important. Okay. It says give the test statistic and the p-value. Okay. So I'm going to stop here for just a second, and I'm going to open up the bookmark site under today's blend, and we'll talk some more about this. Okay, this is today's blend. Here's the bookmarked site. And our sample proportion is 28 out of 60. So I'm going to take a calculator and figure out what 28 out of 60 is. It is 0.46 repeating. So I'm going to do 0.4667. The sample size is how many shots he took. That's 60. And the population proportion estimate, that's the one we're trying to test against, is 0.6. And then the desired significance level, we're going to use 0.05. It's the most common one. Now, some sort of important things. There are a couple different types of alternative hypotheses. Less than, greater than, or not equal to. We have less than. And if you have less than or greater than, you're going to do a one-tailed. If you have not equal to, you're going to do a two-tailed. It's going to double that p-value. We are checking a less than. P is less than 0.6 for all our try that one more time. Our alternative hypothesis. So I'm going to hit, so I want a one-tail. I'm going to hit submit. And one thing that you're going to notice, it takes a second for this site, this EpiTools Z-Test1. TikTok, bro. Here we go. Okay, so those are all of our inputs, and then here's our output. The only two things we need out of here are the z-value and the p-value, but there's a little bitty thing that you've got to remember. If you do a less than alternative, which we have a less than alternative, we're going to make the z-value negative, okay? The p-value is going to remain exactly what we see. So I'm going to do negative, the z-value is negative 2.1, and the p-value is 0.0175. And go back to the notes. Okay, so we use that bookmark website, and we got z is equal to a negative 2.1082. I made negative because of less than alternative hypothesis. And then our p-value is what it is that they said. And we got both of these guys from, we used bookmarked site. And we did one-sided because of a less than or greater than alternative hypothesis. If it was not equal to, we would have done two-sided. Okay, so what does all this mean? Well, if we drew a picture of this guy, this just means that he's falling less than the average, right? Which we know that, like 0.4 something is less than 60%. That's why the z value is negative. That's how many standard deviations he fell away from the mean proportion. Okay, what does the p-value mean? Well, we compare it to alpha. So we write in the conclusion, use alpha equal to 0.05. Let's write this. Using alpha equal to 0.05, since our p-value is less than the alpha value, we reject the null hypothesis. We conclude, so if the null is not true, then the alternative is, we conclude that the true proportion of free throws Mr. Trinfield makes is less than 60%. So I know this is a lot. The good news is these are the only three I'm asking you to do. It's not like, you got a page of 20 or something crazy. And the other good news is you don't have to learn one prob z test and one prob t test and two prob z tests and two prob t tests and so on like you would in an AP Stats class. So we're just doing this one and practicing it 3 times. I don't think it's too bad. So try those, and if you have any trouble, holler at me. Come to office hours and I can help out. All right, adios.